Okay, so Ms. Robertson claims she is an 80% free throw shooter. Through her skills, she shoots 50 free throws and makes 32 of them. Is she exaggerating about her free throw skills? Okay. So, we're going to analyze this. First off, the population. Population is all shots taken. Okay. And then the sample is the 50 she took, that day, at that moment. Okay. So the population is all shots she's ever taken. The sample is the 50 she took at this event. Now, she actually made 32 out of 50. This would be a 5. So that's 0.64 or 64%. So when the pressure was on, she made 64%, not 80%. Now, there's two possibilities why she only made 32 out of 50. Okay. She actually shoots 80%, and it was just a bad day. It was off. Sprained wrist, headache, whatever. Right. Or she made 64% by just a random chance. Okay. So she is actually an 80% shooter, where 64 was just random, just by chance. Okay, so to test her claim, we're going to assume number one, that she is actually an 80% free throw shooter, and examine the likelihood that she makes 30 out of 50 through simulation. So we're going to simulate 50 free throws. Okay? Now here's the thing. We're going to say, she makes 80%, right? Let's go. So if she makes 80%, that's supposed to be a little circle. That means she misses 20%. Okay? So, 100% total. Now, to make life easy for what we're going to do in the calculator, we're going to say, we're going to use the numbers 0 to 9. Because that's 10 numbers. That's going to represent 100%. That was weird. Just move away. Now, to represent on the calculator misses, which is 20%, we're going to use 0 to 1. And that's going to be misses. And 2 to 9 will be makes. This is going to be your 20%, and that's going to be your 80%. So if the calculator gives us a 0 or a 1, that's a miss. And 2 to a 9 is a make. Now, how do we do this with the calculator? Okay. So everybody turn on your calculator. Now listen carefully. Don't get ahead. Don't hit a button you think I'm going to say. Just wait. So get to the main screen. Clear out whatever's there. Remember to quit out of anything in second mode, second quit, and just clear it. Get a nice, empty, clean screen. Now, what we're going to do is we're going to hit math, and we're going to go to probability. You can go 3 to the right or 1 to the left, whatever. Now, we're going to do what we kind of have done before. We're going to hit number 5. Random integer. Don't do anything. You just got random integer parentheses. Okay? Now, for some of you, with the newer calculator, you're going to have lower, upper, and n. All right? So, if you have the school calculators, we're going to say we're going from 0, comma, 9. Comma is above the 7. And we're going to take 50 shots. and then you close the parentheses. Now, don't hit enter, please. Like I said, don't hit a button because you think I'm going to say that. So math, PRB, 5, 0, 9, 50, close parentheses, wait. So for those of you with the newer calculator, it's going to be 0 for lower, 9 for upper, and 50 for your N. So for those of you with the newer calculators, okay, what you're going to do is you're going to go to paste, hit enter, okay, and now you're right where we are. Okay, so if you have one of the newer calculators, go to paste, and you're right matching this screen. Now, we don't hit enter, we're going to hit the stow button down here above on. Stow. Stow. The stow gives us an arrow. Okay? We're going to stow it, store it, in L1. Now, how do we do that? L1 is above 1, but it's in blue. So we're going to hit second 1, which tells it L1. Now we hit enter. Now, what this has done is it gives us a whole list of 50 numbers. You could, arrow over and see, it's a bunch of numbers. We're not going to do that though, but it would give you all of those. So, we're going to look at them in our stat. So if I hit second quit, make sure reset. Now hit stat and hit enter. Now, if you scroll down, don't do it, but if you did scroll down, random, there you go. So if you notice what I'm doing here, I'm going all the way up to 50, and I actually reset. So there's my 50 numbers. But you notice they're not in order, which is going to be very hard to find all my misses, my zeros and ones. I'd have to go through all 50 and keep track. That's a pain. So what we're going to do is we're going to sort these. Okay? So hit second quit again. Now hit stat. Number 2, stat A, sort A means ascending. So hit number 2, and we have to tell it, don't hit anything, to look in L1. Close parentheses, enter. And you should have done. Now, when you hit stat, and you go to edit, look what you got. You should have a bunch of zeros. Some of you might have some zeros and ones. All right?
I only have like 4 zeros.
Like I said, some of you might have fewer zeros and then 1. That's just random. All right. So now it's going to be very easy for everybody to find their misses, which is going to be a 0 or a 1. Now watch how easy this is. You don't even have to count. Just scroll down until you get your last one. Now, see, I went past my ones, right? So I'm going to go up to my final one. And it tells me right here, L113. That's weird. It's the exact same number I got earlier on a different calculator. So I have 13 misses. So I got 13 out of 50 misses, which means I got 37 out of 50 makes. So that's 26% in, I'm sorry, no, out, miss. 26% miss and 74% make. For you, it's all going to be different. Okay, so for me, and oddly enough, it's the same one I got before, simulate 50 free throws, we just did that. So I had 74%. You are going to write down your percent that you got. So yes, we're all going to have some different numbers. Some people may have the same thing. Likely there's going to be a couple people who got, 74, 80, whatever, but I got 74%. We're also not going to do number 4. We're not going to repeat this again. It would just mean going back in and doing it again and getting 50 different numbers. For me, I didn't get that luck. I hit the same number twice in a row today. Okay, now, real quickly, on your chart here, on your paper, start with the second line, put 0.1, skip a line, 0.2, skip a line, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. You should have started with the second from the left and ended up on second from the right. Now, if this is 0.7, that's 70. This is 75. That's 80%. So for me, 0.74, I would put a dot right about there. Okay? So there's my dot. Now everybody's going to come up and put their dot on the screen. I'm going to stop recording. All right. So it looks like we have up here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, possibly 20 dots. Okay? But notice, where are they? They're all between about 70% and 90%. That's going to be important. All right. Now, what does each dot represent? Okay? It's a sample of 50 free throws percentage made. So each one of those is a sample of 50 and the percentage made for that sample of 50. Because each one of us ran a simulation with 50, and that's our percentage. Okay, on the next page. We're going to get this done. So number 7, it says, based on the simulation results for the whole class, how likely is it for an 80% shooter to make 64% or less when she shoots 50 free throws? So I'll go back. You don't have to. Look where 64% is. Okay? That's 64% or less. Did we have even one dot, even one, randomly below 64%? No, we did not. Now, if we did this another time, and another set of times, and another set of times, and another, maybe we might start getting some below. But with that big of an amount to the right, not even close, what is our chance of getting 64% random? Yeah. 0 out of 17. So the probability of F being less than 0.64 is 0%. There's no chance. And if there was a chance, it'd be a slight one. We'd have to run the simulation over and over again, and it's probably still not going to happen. So, based on your answer to question 7, does the observed 64% give convincing evidence that she is exaggerating? Or is it possible that she just by chance had that bad of a performance if she truly was an 80% shooter? Which is it?
She lied.
She lied.
She's a liar.
She's exaggerating. Okay? Because even by chance, none of us got 64%. Okay, so just some filling in now. In the last unit, our goal was to create an interval of plausible values for a population parameter called the confidence interval. Okay? We're going to be this time using claim. Whoopsie. Love this board. Come on, really? There. Haha, I tricked you. That word claim is important. Okay? We're going to be talking about claims in this unit. And we're going to claim whether our hypothesis is plausible, realistic. Like we just did. She made an 80% claim. It wasn't plausible. So a hypothesis is a claim or a statement about a single population parameter, like making free throw shots. So, for example, very popular example, politician claims majority of citizens support Social Security reform. So he takes a random sample to see if that data supports greater than 50%. Okay? That is what he's projecting for. So this is greater than 50%. 0.5 is 50%. Now, these two terms are the same, a hypothesis test or a significance test. It is a method for using data from a sample to decide between two competing hypotheses about whatever parameter we're talking about. So, of course, it would be very easy if we did a census. If we asked everyone in the country, always, but we have to take samples because census is not realistic. So a good analogy for hypothesis testing is the American judicial system. In a trial, there are two competing hypotheses. Only two. Guilty or innocent. We assume innocent until proven guilty. All right? So therefore, we're going to have one hypothesis as our basis, and then the rest is to prove it wrong. So, a significance test. We just talked about our hypothesis test. We'll start with a careful statement of the claims we want to compare. So, in our analogy of the judicial system, the null hypothesis is we're assuming innocence. Okay? The null hypothesis is what we seek evidence against. That's our starting point. So, with our analogy, I'm going to say i.e. assumed innocence. And please write this down because it references what we were just talking about. That's not how you spell innocence. That's not how you erase. That's not how you erase either. What is happening here? Go away. Innocence. Okay? So, in the judicial system, assuming innocence is our null hypothesis. And yes, get the giggles ready, it's H sub O, which is ho. Yes, I get it, ho. Ha ha, giggle, giggle out now. Okay. Now, the claim we hope or suspect to be true instead of that is called the alternative hypothesis. Alternative starts with an A, so we call it H-A, ha. We're going to call it ho and ha. Ho, 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 ha, 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 ha. Okay, that's what we're going to be referring to. This is, back to our other example, guilty. So, assuming innocence is our null, ho. Proving guilt is our ha. Now, in general, this is the format it's going to be in. Okay? So we're going to always say H sub O colon P equals, and then we're going to have a decimal right there. And then we're going to have ha colon P, and there's three choices here. We can have less than, greater than, or equal to the same decimal. That's very important. This decimal will always be the same. All right? Same decimal. So the alternative hypothesis is one of three things. Greater than the value in the null, less than or equal. Same decimal. H-A and H-O. P is equal to, and then P is either less than, greater than, or equal. Those are your three choices. So let's go back to the free throw example. The null hypothesis is P equals 0.8. That was her claim. Her claim was, I'm an 80% shooter. The ha, did we believe her? Did we think she was that good or less than? Yeah, so our ha was less than 0.8. So her null hypothesis, I shoot 80%. We don't believe you. We think it's less than that. That's the ha. So, two quick examples and then we're done. Nope, that's not what I wanted. There we go. So, Rob once read that 1/4, this is important, 1/4 of all people have played or danced in the rain. So your little kid starts raining, you're like, yee, you're running around playing in the rain. Okay? Splashing in puddles, whatever. I think it's a pretty fair supposition. I would say a lot of people probably played, at least when they were a kid. But we're going to ask high school students who are too cool for that. So, they asked in their high school. And his friend Justin thinks thinks that Rob's value is too high for their high school. To settle the dispute, they ask an SRS, R being random, and find 80 students surveyed. 12 said they played in the rain. Okay. So, the hoe. P is equal to, what is he claiming? What percentage played in the rain? No. What is Rob claiming? 0.25. He claims 0.25 played in the rain. The ha. And yeah, his friend Justin thinks less than 0.25. That's the ha. Because his friend said, I think that's too high. So he thinks it's less. Number 2, according to the website, sleepdeprivation.com, 85% of teens, 85%, are getting too little sleep on school nights. Oh, sorry, I forgot to write the proportion up here. That's our favorite sentence again. Let's come up here and get the board to work. We have to write what the proportion is we're studying. So P is, and there's going to be that repeat sentence, the proportion of all people who played or danced in the rain. So this is just like we did with confidence interval. We just do the same thing. We just write out, what are we claiming? What are we trying to claim? We're trying to prove the proportion of all people who played or danced in the rain. So for number 2, we start off by saying the P. And again, same words. It's going to be the proportion, this time, of teens, and you can just see the sentence right here, of teens not sleeping enough on school nights. So in other words, that's what we're studying. We're investigating the ones who do not get enough sleep on school nights. So, the ho and the ha. The ho, he's claiming, right, the guy is claiming 85%, because this is all, remember, the ho is always equal to a decimal. So, ho equals 0.85. Now, this one's a little bit different. Jamila, the friend, asked 100 people, and she's just trying to prove if it's right or wrong. She's not making a claim that she thinks it's less. She's not making a claim she thinks it's more. She just wants to know, is it true? So if she's just trying to prove if it's true or not, that's going to be, she's trying to prove whether it's not equal to 85. No, because she is not making a prediction one way or the other. She's just saying, I want to know if it's true.